You know how you read a document? You don't just start at the top left word, right? Of course not. You glance at the whole thing. You see the columns, the pictures, the tables. You get the gist of it before you even start reading. Well, what if an AI could do that too? Today, we're going to look at a brand new model that reads just like a human. And honestly, it's a way bigger deal than it sounds. Okay, let's just jump right in. Take a look at this. It's a mess, right? A crumpled up, handwritten note. Most OCR systems would just give up. But Deepseek OCR2, it nails it. And look closer. It even knows that a word has been crossed out. I mean, think about that for a second. That's not just reading letters. That's understanding what the person meant to do. It's interpreting intent. Wild. All right, let's try something a little more structured, something we all know and love. Invoices. They're full of tables, lines, columns, a nightmare for old school OCR, which would just spit out a jumble of words and numbers. But this thing? Nope, it sees the table and just pulls it out. Perfectly structured, ready to use. This is an absolute game changer for anyone who has to deal with data entry. Okay, but this is where my mind was really blown. We're not just talking about reading words anymore. You give it this complex 3D figure from a scientific paper, most AIs would just try to read the labels on the axes, right? This model gives you a description of what the figure is actually showing. It understands the meaning. That is a completely different level of comprehension. It's not just reading, it's understanding. So, what is this thing? What's the magic behind what we just saw? This is Deepseek OCR2. And get this, it's not just some small update. It's a complete redesign from the ground up. And it came out only 3 months after their first version, which was already pretty impressive. So they're moving fast. So what's under the hood? Well, it's a vision language model, and it's built to be bilingual, which is awesome. It handles Chinese and English really well. But here's the part that really matters, especially for all you developers and creators out there. It's actually usable. Like, for real. The whole model is under 7 gigs. It runs on about 8 gigs of VRAM. That means you can run this on a normal consumer graphics card, right on your own computer. That's a ton of power to have at your fingertips. All right, so how on earth does it do this? How does it get that human-like intuition when it's reading? Well, the secret sauce is this new idea they call visual causal flow, and it's all about one simple but powerful concept: how the model sees the page before it ever reads a single word. And this right here is the big idea. Think about old OCR. It reads like a dumb machine, right? It just starts top left, goes line by line, and if it hits a column or a table, it gets totally lost. Deepseek OCR2, it reads like you do. It glances at the whole page first, figures out the layout, and then it starts reading along the path that actually makes sense. It's so simple, but so smart. The piece of tech that makes this all possible is called the Deep Encoder V2. It completely changes how the AI processes what it sees. Imagine you chop up the document's image into a bunch of little puzzle pieces. These are called visual tokens. Instead of just feeding these pieces in one by one in a dumb order, the encoder is smart. It looks at all the pieces and rearranges them based on how the document is actually laid out. It's basically creating a smart reading plan before it even starts. So it all boils down to this really elegant 2-step dance. Step 1 is layout reasoning. The smart encoder scans the whole document and figures out the best way to read it. It creates that logical path. And only then does step 2 kick in, content understanding. The decoder follows that smart path and reads everything in the right order with the right context. It's so simple when you think about it. Reason first, then read. That's the whole game. Okay, so this whole new way of doing things isn't just a cool science project, right? It has real-world benefits, big ones. Bottom line, it's smarter, it's faster, and it's cheaper. Let me show you what I mean. So check out the numbers. The benchmarks are pretty stunning. We're talking about a nearly 4% boost in performance on really tough document parsing tasks. But here's the real kicker. It gets that better score while using fewer of those visual tokens. You know, the little image pieces we talked about earlier. So what does that mean? It means it's not just more accurate, it's way more efficient. It's doing a better job with less work. And you know, this isn't just about one cool model. This is part of a huge trend we're seeing across the entire AI industry right now. You look at models from GLM, Minimax, Moonshot, all the big players are chasing the same thing. How do we slash the computational cost while at the same time cranking up the performance? And why does that matter to you and me? Because it means the incredible AI tools we're all using are getting faster, cheaper, and easier for everyone to get their hands on. It really is the name of the game in AI right now. Do more with less.
So you can see we're way beyond just turning pictures of words into text files. This is about real, true comprehension of all the documents in the world. And that leaves us with a pretty mind-bending question to think about, doesn't it? When we have an AI that can read anything, from that crumpled note all the way to the most complicated scientific paper, and understand it instantly, what are we going to find? What hidden knowledge, what secrets are locked away in billions of pages right now, just waiting for us to finally be able to read them all?